In this video, we'll be taking a look at the Lesson 5 packet for Bootstrap World, in which you will be learning how to write a design recipe and what's involved in actually writing a design recipe. So, number one, defining a value is helpful when a program has lots of identical expressions, like if we wanted 50 green triangles all the same size. But what if a program wants to use 50 green triangles of different sizes? Sometimes a program has expressions that aren't identical, but very similar. We will create a function that will always produce a solid green triangle as the output, or the range, but will specifically take in the size as an input, or a domain. So we're going to be creating a shortcut that will always make a solid green triangle, but the size will vary. So in number 3, it describes the function. We will define a new function called GT, a shortcut for green triangle, that takes in one number and always produces a solid green triangle of whatever size we specify. So 3 really important things here. The name of the function is GT. The word problem describes that the function takes in one number and always produces a solid green triangle of whatever size we specify. Those 3 important things will be necessary as we create our design recipe. So as a couple examples, we're going to be teaching the computer a shortcut called GT. So when I type in my shortcut, GT10 specifically, it's a shortcut for writing it out the long way. Triangle, size 10, solid green. Along those same lines, GT20 is going to be a shortcut for triangle, size 20, solid green. And again, a little bit of repetition doesn't hurt. GT 180 would be a shortcut for triangle, size 180, solid green. So we're going to be teaching the computer basically this shortcut so we don't have to type it in the long way every single time. So how to create a design recipe. When you click the recipe button at the top of our website, our editor, this is what comes up. You can see that there's 3 parts to a design recipe. The contract, which we've discussed a lot so far. Examples, which is where we teach the computer how to use our shortcut function. And then the code, which is really the definition. It's actually the most important part of the design recipe. So step 1, write the contract. In our example, the name of the function is GT. They told us that in the word problem in number 3 up above. The domain of the function, it says GT takes in one number. So the domain is a number, and it says the function produces a solid green triangle, which means our range is an image. So when we put those in the appropriate places in the contract, we get that GT takes in a number as the domain and produces an image as the range. That's our contract. That's step 1 in the design recipe. Step 2, give examples. We have to actually teach the computer how to use our new function. So this programming language provides a special construct called example, which helps you write down how the function is used and what it should compute. Here are 2 examples. You'll notice we have open parentheses and closed parentheses at the end. And inside those parentheses, we have the word example, GT50, triangle 50, solid green. So basically, we're teaching the computer what's the shortcut I'm going to be using and what would be the long way to write it. We have to teach the computer that the long way is now going to be done using this short way. As another example, GT100, any other number, any other size. The long way to write it, triangle 100, solid green. So when we want to actually write our examples, we need to use the shortcut function first and then teach the computer what to do with it using a function that the computer already knows. So the computer already knows how to create an image of a triangle. We're just trying to create a shortcut. So in our 2 GT examples, the code is almost identical except one thing. Circle the only part of the code that changes and give it a label. Okay, what does the number represent in the GT function? So I actually want you to physically circle the only part of the code that's changing. The 50 and the 100 are different, and the 50 and the 100 are different. Everything else is the same. Example, example, GT, GT, triangle, triangle, solid, solid, green, green. The only thing that's different is the number. what does that number actually represent? We could use any word here, any variable name, but you do want to make sure that it's a good description of what that number represents. It actually represents the size of the triangle. So the number represents the size, so I'm going to use the variable size in place of a specific number like 50 or 100. So can you come up with two of your own examples for the function gt? We'll do one together and then I'll have you pause the video and do one on your own. So for example, on the first line, which is actually going to be the first box when you're actually typing in the computer, we want to type the shortcut for the computer. So when I type in GT7 in the second box or the second line, what do I want the computer to do with it? I want it to create a triangle, size 7, solid, green. Based on the two examples that were given and the one example that I just did for you here, can you come up with your own example? Keep in mind, the only thing you have to get creative with is the number. Pick any number. Everything else stays the same. So pause the video now and do the second example on your own. So here's an example of what your example might look like. The only thing that might be different is instead of the number 75 here and here, you can have any other number. Even decimals or fractions, big numbers, small numbers will work. So after we write our examples, we do have to identify what's the only thing that's changing. The only thing that's changing is the number, which represents the size. Labeling these with the word size is going to help us when we go to step 3 in the design recipe, which is to define the function. So when we define the function, after writing the contract in 2 examples, and after you identify where the difference in the code occurs, defining the function itself is relatively simple. 3 important things. Copy everything that stays the same, so everything that wasn't circled, in one of your examples. In place of each circle, write the label you gave to that circle and change the word example to define. Now the editor or the design recipe that we're going to be using within the editor already has the words example and define there. So the word example and example shows up in the examples, but the word define shows up in the definition. GT stays GT, and instead of the specific number 50 or 100 or 7 or 75, we're using the variable, which is size. Close the parentheses, open the parentheses. We want to teach the computer that it needs to create a triangle, so triangle stays triangle. Instead of a specific number, we're using the variable size. Solid stays solid, green stays green, close the parentheses, and then of course the whole line of code needs its parentheses closed. So that is our definition. So how does this work in the editor? Well, you'll notice on the next page of your packet, page 3, that you are supposed to be opening a new program in wescheme.org, calling it your last name, lesson 5, and you're going to be using the recipe button at the top to actually type this recipe in. So since you're on a computer of some sort watching this video, if you can get your hands on a keyboard and open up wescheme.org in Google Chrome, open up a new program, call it lesson 5, and we're going to be using this recipe button at the top of wescheme.org to be typing in this recipe. So I'm going to move my bar over so I can see this whole thing, and I'm going to get typing. My contract, GT, number, image for the output. Example, when I type in GT50, for example, I want the computer to create a triangle, size 50, solid, green. Close the parentheses. The box will turn green once you have closed the parentheses. Second example, when I type in GT100, that's my shortcut. What do I want the computer to do with it? Create a triangle, size 100, solid, green. Lastly, the definition. When I type in GT size, in general, I want the computer to create a triangle, whatever size I used in the first set of parentheses, solid, green. Everything that stays the same stays the same. Everything that is changeable, you give a variable name like size and use it in both boxes for the definition. So now when I click insert, that's my design recipe. When I click run, I should get no errors. If there were any errors, it would highlight the error and tell me over here what's wrong with it. But now that I've clicked run, on page 3, it says now try using the GT function for various sizes. Try GT10. It worked. That's a green triangle size 10. Try GT35. That's a green triangle size 35. GT500. Green triangle size 500. Very big. So we can't see the whole thing. But that's okay. We know our function works. So notice that GT is a shortcut to getting a solid green triangle instead of typing the code every single time. So your task for the rest of lesson 5 is to complete tasks 2, 3, and 4. And after you finish all 3 of those, you need to get signed off on your lesson 5 packet by showing that not only does BC work, which is task number 2, but dot also works, that's task number 3, and half works, which is task number 4. So I'm going to ask that you pause the video and try these 3 design recipes on your own, and then come back and watch the rest of the video and we'll go over it. So this is what your design recipe for BC should look like. Pause the video now if you need to check it carefully. Otherwise, I'm going to show you what it should look like once it's typed into wescheme.org. So what I did here is I used my recipe button to carefully type in the contract, the examples, and the code, and I clicked insert, and the design recipe for my BC function was inserted in the definitions window. So now in the interactions window, I should be able to evaluate the function BC with any number as an input, indicating the size of the blue circle. So I've now taught the computer a shortcut to create a blue circle. Instead of typing out circle 100 solid blue, I can just type BC 100. So let's take a look at the next page, task number 3. If you haven't done it already, pause the video and do it yourself now. If you need a couple hints, here they are. Write a recipe for the new function called dot. So the name is dot. It should take in one color as an input. Keep in mind, a color is not a number this time. A color is a string. So the domain is a string, but it will always produce a solid circle of the given color, always with a radius of 20. So the range is an image. I've done one example for you. If you need a hint, take a look at it. We're using dot with any color as an input, written as a string between quotation marks. What we want the computer to do is create a circle, always size 20, always solid, using whatever color I used on the first line or on the first box of this example. So use this example to help you finish the second example and the define statement if needed. Pause the video now if you need to. Here's what the rest of the design recipe should look like, keeping in mind you didn't have to pick yellow and purple. You could have picked any colors for these examples. Once I had my second example written, keeping the size 20 constant, I circled the parts of the code that was changeable, which of course was the yellow and the purple, and I gave it a variable name, which in my case I thought the word that best described it was the word color. So let's take a look at how this looks when we type it in. Here is the design recipe all typed in for my dot function. Keep in mind the word color is a variable, so it is not between quotation marks. Once I click insert, it inserts the design recipe in the definitions window. I click run, I get no errors, which is good. So now when I use the function dot with any color as an input, I get a size 20 circle that is the color that I said. So let me try one more, dot dark blue, and it works. The dot function will always be the same size, but it will be a different color. Go ahead and try task number 4 on your own if you have not already. Pause the video now. Here's the design recipe for the half function. Let's see what it looks like in our editor. Here's my design recipe. I click insert, and run, no errors, and now half 40 works.